Q10. So where are we going to start with this one? First of all, I see I've got a function, an equation, right? And I'm going to do complete, and then I just kind of peek, and we're dealing things with inverse functions. Remember, the inverse basically just switches the x and the y, so the input and the output. So here's the forward function. I'll call it f of x. And the inverse function, and again, notation sort of changes, really should be that y is the input, x is the output. So it kind of, you get basically swapping the x and the y as far as how it's being used. So let's see if we can go through this. One of the key parts is seeing that we have two variables, okay? So an x and a y, but in this case, they're using capital T and little h. So let's define what the units are on these variables, because that's going to help us when it says, when we're trying to describe this. Notice they're using units. So scientists found a relationship between the temperature and the height above a distant planet's surface, T of H. Given below is the temperature, and so T of H, or just T if we want, is the temperature in Celsius. So we're looking for the word Celsius or something dealing with temperature. T will always be that. That never will change, whether we're dealing with the inverse function or the forward function, as I like to call it. It's going to be Celsius. The height K in kilometers, H in kilometers, maybe it should be K, H for height, that's going to be kilometers. That will never change. H is always going to be representing kilometers, height above, even when we switch the order of how we're putting it in, right? So let T inverse be the inverse function of T. Okay. We don't have to, well, we'll find it later. Take X to be the output of the function T. Okay, that is X equals T of H. And give us another variable, right? And so H becomes equals to T inverse of X. Okay, basically, because that would be confusing to have T inverse of capital T, but that's actually what's happening. So when we look at this, what is X? X is actually temperature. Okay, so we're going to say they gave us capital T, but now they're saying, hey, let X be capital T. Another extra step in here, but now whenever we see X, we know that that's a Celsius. H is a kilometer. Okay, the height above the surface in kilometers. So what is this symbol? Notice that's the output. When the temperature is X degrees Celsius. Okay, that might fit. The height above the surface in kilometers when the temperature is X degrees Celsius. X is supposed to be Celsius. This, if you'll see, is actually equal to H. The inverse of X is equal to H, which is kilometers. That's making a lot of sense right now. I'm going to read the other ones, but I'm going to say this is what, I'll put a check mark. This is what I believe it is. Unless I get the temperature in degrees Celsius at a height of X kilometers. That can't be it, because I know X is not kilometers, it's Celsius. So that one I can get out of. The ratio of the temperature in degrees to the number of kilometers. That'd be something like a slope, and we're not talking slope. So, and they're saying X is kilometers again, so that doesn't make sense. The reciprocal of the temperature, and again, if you see the words reciprocal, they're trying to play off this -1, because that's another way, when it's an exponent, this is not an exponent -1, this is a symbol which means inverse. It's a little sad that they used it, and then they also use it for the inverse. So if I do 2/5 to the -1 power, that's not an inverse function. That is the reciprocal. That's equal to 5/2. Okay, so it's a symbol that's used for reciprocal. That's what they're doing here. That's not it. And again, you can also see this. They're saying x is in kilometers. Another way we can see, no, x is not kilometers, it's Celsius. So I'm very confident now because I've been able to get rid of these simply by saying, no, x is not kilometers, x is not kilometers, x is not kilometers, oh, x is Celsius. That's the only one. 100%. Not even 99.9. I'm 100% confidence with this one. And hopefully you will be too. So let's go ahead and mark that. That's our answer. Now we have to find that inverse function, and then we're going to have to plug in the 25 and do it. Remember, the 25 input, that another way you could put 25 here and just solve the forward function. That could be it. In fact, why don't we do that a little bit differently, and then I'll come back and do this. So remember, this 25, it's an input into the inverse function, which means it's an output into the regular function. So you could just, if you struggle a little bit with inverses, just say, okay, 25 is going to be the output of the forward function. And then I just solve for h. And that's what we're going to do, basically the same thing when we go for the reciprocal function, or sorry, no, see, this is even throwing me off. When we go to the inverse function, right? H is what the inverse function is. So we're going to solve for h. Okay, minus 38. You get negative, that's 5 plus 8 is 13. Negative 13 is equal, this gives you 0. 0.25h, and then just divide by negative 1.25. And we're going to get that h is equal to positive something, or 13, divided by 1.25. And the negatives are going to cancel. 10.4. So it's 10.4 kilometers high. At 10.4 kilometers high, the temperature is 25. So we know what we're talking about now. Hopefully. And that will help us also with this inverse function. So and kind of thinking how we're going to go about this. So we take our forward function, and they tell us we want to kind of do it all in variables, let x equals t of h. Okay, so we're going to rewrite it. Let's change color here. X equals, I'm taking my function, 38 minus 1.25 h. I could have just used capital T, but that's what they want us to do. Now what I've got to do, I do this as a first step. I could solve it for h and then switch, but what I'm going to do is I'm going to do the switch of variables. That's what gets me the inverse function. So x becomes h becomes x. Now I solve it for x. Wait, do I do that? Oh, their notation gets me confused. Let's see. Which is the inverse? Usually what we do, I solve for x. Back to that. Then I'm calling it the inverse function. You input it, you get your h. To have the notation right, this is going to mix up. So let me back up. Because of the way they have this set up. Usually we just set up with x and y, so usually we do this step here. What we're going to do is they've kind of already done the substitution for us. So we're going to solve this for h, kind of like the steps we just did up here. But instead of having a number in for x, we're just going to leave x as x. So we subtract 38. And we get x minus 38, equals negative 1.25h. And then what's the next thing we do? We divide both sides by negative 1.25. Negative 1.25. And again, if I had a number here, I would have done the subtraction and did this. And if we did that up there, this is 1, so that's what h equals. And what is h? Because of the notation, that's our inverse function. So we can rewrite this as x minus 38 over negative 1.25, right? Just what we did up here. That's our inverse function. That's our h, but h is also written as this. Plug in. So if you give me the temperature, it will be able to determine the height. Okay. Again, this is sort of different. I think it's a better way of doing it, but it's not the way I learned it initially, and so I still struggle a bit with it. But I think it's a little bit, hopefully, clearer as long as you follow through. And if you do the C part first, that makes more sense. You plug in for it, you solve it, you know what's happening. You know when you go to find the inverse function, you're going to basically be doing the same thing. But we just got to be careful to get all our notation correct as well. It's a little tricky. I could just leave it like that. You could also distribute this negative up, and so it could be negative x plus 38. That's still a correct way to write it, but I like to do as few adjustments as necessary. Okay, so that's number 10.